Good morning class. This is the 7th class of compound interest and this will be the last class of compound interest. As you all know, in my previous class I have given you one homework which is sum number 15. So I'll do that first and then I'll move on to my next schedule of discussion, and I'll do the two sums from there, and then the two sums will be the homework, and that will be the end of compound interest. Next, from my next class onwards, I'll obviously solve the sum of the two homeworks in my next class, and then I will start with annuity next time. Okay, I'll discuss that, then I'll move forward. Again, I have given you the sum number 15, which is given that in what time, means time means number of years you have to calculate. At what time will rupees 5,000 amounted to rupees 5,832 at 8% rate of compound interest? We don't know the time. So let the time be in years. You know P, which is 5,000. You know A, which is 5,832. You know R, which is 8%. Same formula. P into 1 plus R by 100 whole to the power n. 5,832 is equal to 5,000. 1 plus R is 8 by 100 whole to the power n. Or if you divide that with 5, you will get 25. If you divide that 25, this is 6, this is 7, this is 2, this is equal to 9, and this is 625. Yes, 625. 108 by 100 to the power n, or 729 is equal to 625 divided by 4, means 27 by 25. Sorry, 27 by 25 whole to the power n. Okay, or 27 by 25 whole to the power n is equal to 729 by 625. What is that? 625. If you divide it by 25, 25 means, yes, this will be 1, 2, 3, 4, 5, 6, 7, 8, 19, 20, 30, 40, 25. This will be 25, or 27 by 25 whole to the power n, means 25 square is 625 and 27 square is 729, means this is the square 2. If you deduct that, if you cut that, or n is equal to 2 years, means it's 25. If you are dividing with 25, you are getting 625, and if this is divided by 27, it will be 729. Okay, so I am just making that 27 by 25 n is equal to 729 by 625. The 625 square is 25 square is 625 and 27 square is 729. If you cut that, n remains 2 years, so n is 2 years. This is the answer. So in my today's class, this is the homework of the previous. In my previous class, I will discuss about the uniform increase or uniform decrease. Decrease means you know that depreciation, and uniform increase means the growth. In case of growth, you know the same formula will be applicable. P will be the initial value. If the rate increases, then the growth will also increase. So in that case, for formula for growth, remains the same, which is A is equal to P into 1 plus R by 100 whole to the power n. This is compounded for annually. If it is annually, if it is half yearly, it will be A is equal to P into 1 plus R by 2 by 100 whole to the power 2n. The same formula. But for depreciation means P will be the initial value if the value decreases yearly at the rate of R%. Then the final value of A after n years means formula for decrease or growth or depreciation or decrease annually, what will be? It will be A is equal to P into 1 minus R by 100 whole to the power n. It is always calculated annually. So these two formula I will be doing in my today's class. So these two sums I will be doing. The first sum is given as the population of a town increases every year at a rate of 10%. The present population of the town is 60,500. You have to calculate the population of town 2 years after and 2 years before. Means you have to calculate the population 2 years after as well as the population 2 years before for the town. How you can do that? It's easy. Now the present population is given 60,500, right? The present population is given 60,500. So I'm rubbing this also. Present population is given 60,500. First present population. This is sum number 1. Present population or P is given 60,500. R is given 10% growth. So let A be the population after 2 years. First you have to calculate after, then before. So the same formula, A is equal to P into 1 plus R by 100 whole to the power n is equal to 60,500. 1 plus R by 100 means 10 by 100. Whole to the power n means 2. 60,500 11 by 10 square. 60,500 into 11 by 10 into 11 by 10. It is coming 73,205. Means after 2 years the population will become 73,205. What will be the population before 2 years? Present is this one. Means before 2 years means obviously it will be lesser than 60,500. So in that case, let the population 2 years before was P. Also I am considering P. Therefore, the population 2 years after means present. That is present population, because 2 years before means this is the present. 2 years before means the way back 2 years. That time the population you don't know, you have to calculate. But the present population you know 60,500, and after 2 years what will be the population you know? 73,205. Sorry, 205. So in this case the present population is 60,500, okay, which is A. Sorry, you have to calculate E. So now A is equal to P into 1 plus R by 100 whole to the power n. A is 60,500 is equal to P into 1 plus 10 by 100 whole to the power 2, or 60,500 is equal to P 11 by 10 square, or P is equal to 60,500 into 10 into 10 by 11 into 11. It will become 50,000. So 2 years before the population was 50,000, and 2 years after the population was 73,205, and the current population is 60,500, and the growth rate was 10%, means R is 10%, means in a 10% growth rate per year it is growing. So 2 years before it was 50,000, after 2 years it was 60,500, which is the present. Now after again 2 years, means total of 6 years, it will be 73,205. Each year it is growing, so it is the growth percentage I am using. Okay, the next sum which I will be doing it as the depreciation formula will be applicable, which is the sum is given as a machinery depreciates at the end of machinery depreciates at a rate of 10% of its value at the beginning of a year. Means the machinery has been depreciating its value, which is 10% every year at the beginning. And if the present value is 8,000, find the value after 3 years. Present value is 8,000. It is depreciating at a rate of 10% per year. So what will be the value at the end of 3 years? You have to calculate that. How you can calculate? You can easily calculate that in the later part. I think it is visible now. Yes, it is visible. I am doing it. See, it is sum number 13. Present value of machinery is provided, which is 8,000. It is 8,000. R is rate of depreciation. Rate of depreciation is 10%. So let A be the value of machine after 3 years. Then you have to calculate the formula. A is equal to E into 1 minus R by 100 whole to the power n is equal to 8,000 to 1 minus R is 10 by 100 whole to the power 3 is equal to 8,000 into 100 minus 90 whole to the power 3 is equal to 8,000 90 by 100 whole to the power 3 is equal to 8,000 9 by 10 whole to the power 3 is equal to 8,000 into 9 into 9 into 9 by 10 by 10 by 10. I mean 9 by 10, 9 by 10, 9 by 10. If you calculate it, I am doing it in my calculator. The value of machinery is coming 5,822. After 3 years, the value will decreases from the current value of 8,000 to 5,832. This is the value which we will be getting after 3 years. This is the value which you will be getting after 3 years. So these are the two sums I have provided. This is the depreciation formula I have provided with you. And again, I will be providing two sums in homework with the help of the same formula. I think you can able to do that. This is sum number 3, sum number 3, I am doing sum number 1 and 3, and obviously I will be giving you sum number 2 and 4 as the homework. And this is the conclusion of compound interest chapter. In my next class I will discuss annuities, and again I will solve these two which I have given you as the homework. Thank you very much for the class. Thank you very much.